So you guys have definitely have a lot of experience writing equations and lines. Okay, some of you guys have done a lot of in Algebra 1. You would have worked a little bit in geometry. It's not anything new. I think the main thing was that we were looking at the online homework stuff and trying to get you guys ready to do more of that. And there was just some skills that kind of seemed like that we were afraid that wouldn't be there if we didn't go back over them from 2 years ago. So be able to write the equation of a line, be able to look at a graph of a line and talk about its slope and its y-intercept and stuff like that. And then moving towards like being able to graph absolute value problems is where graphing lines and graphing absolute value problems is what that packet of stuff you guys are going to pick up is all about. So we want to go back over that so we can then transition into some other things that are on the online platform. So I want to make sure those skills are there first. So if you're writing this down, slope-intercept form is the first thing we're talking about. And, what does that look like? So when you write slope-intercept form, what does that look like? Of course, that's just y equals mx plus b. Or f of x equals mx plus b. So in the y form or in the function notation form. Okay? And then, when we're talking about slope-intercept form, we're talking about the slope of the line. And then we also talk about the y-intercept of the line. I want to kind of go into some details, though, about slope and y-intercept. Again, anything I'm writing down that like as I'm writing it, like, oh yeah, I remember that, like, then you don't need to worry about it. But if it's anything that's like, ooh, I kind of forgot about that, or oh, that sounds different than the way I normally think about it, then you might want to write those things down. So we talk about m, we talk about slope, we're talking about rise over run. Okay, which means that we are talking about the change in y over the change in x. And there is a formula for slope, which we don't need right now, but I'm just going to go ahead and write it down. Y2 minus y1 over x2 minus x1. Okay. So think about what slope means, right? And then, what's a y-intercept? Okay, that's the point where the graph crosses the y-axis. And we know something about that, right? It's a point, so it has coordinates. And we know that all y-intercepts have an x value of 0. And that's actually a really important point. So when you talk about y-intercepts that that means the x value is 0 is actually a big deal as far as stuff that we do in this class, for this graphing and talking about different functions and solutions to those functions and things like that. Be able to identify the y-intercept or x-intercepts, based off of this property they have is really important. So, highlight that. And this is something that you guys need to make sure that when you talk about a y-intercept, that means the x value is 0. Okay. Anything there with slope or y-intercept you guys want to talk about? This will be the part where I say, am I on mute? Because nobody's saying anything.
No, you're not. We're just quietly paying attention.
All right. So what we're being asked to do here, all right, so we're going to write the equation in slope-intercept form, then we're going to indicate the value of the slope-intercept, okay? So we're just going to go through a couple of these. We won't do all of them, but we'll go through a couple of them. Yeah, it's going to start off pretty basic. Let's look at this first one here. So is it in slope-intercept form, right? Is it in y equals mx plus b? You can see that y is by itself here, y is by itself here. So that's really kind of the biggest thing. Y is by itself. So this one's already in slope-intercept form, so there's nothing for us to do there. So that means we should be able to identify what the slope is and what the y-intercept is. All right. The slope is always the coefficient of x. And so in that case, that'd be the slope is 2/5. And the y-intercept is always the constant. And so what I'd like you guys to do is go ahead and write that as a point, though. So that'd be 0, 7. Okay, so once it's in slope-intercept form, finding the slope and finding the intercept should be easy, right? That's why it's called slope-intercept form, because it tells us those things right when we look at it. So they shouldn't be hiding from you when you do that. It shouldn't be a big deal. Second one's pretty similar, right? It's just in the f of x notation now. Right? F of x equals x negative x plus 2. Okay. But in the same way, right? The f of x was by itself here, right? There's all the other stuff is on the right side. So f of x is isolated, so this means this is in slope-intercept form already. So that means you guys should be able to tell me what the slope and what the y-intercept is. All right, Peyton's saying that the slope is -1. He could have done that publicly. He chose to do it privately for some reason. He's also saying privately, for some reason, that the y-intercept is 0, 2. Remember that -1 could also be written as -1/1. That we can, we think of slope as a rise over a run, so that it has two values. The top number means something, the bottom number means something. So we often think, even though it's simpler to write it this way, that sometimes we need to make sure we think about it this way, that it's two numbers. So. Anything on those first two you guys want to talk about before we move on to the ones that are a little bit trickier? Anybody besides Peyton going to talk today? Anybody? Hello? Anybody? All right. I did. Okay. Let's looking at 9, right? Or 3, whatever you want to call it, doesn't matter. All right, so does this fit the form of slope-intercept form, right? Is y by itself? And in this case, no, right? So that's our goal here, is to get y by itself, or isolate y, or solve for y. And since we are solving, that means we should be using our good buddy SADMAT in order to make sure that we solve in the right order, right? So if I'm trying to get y by itself, right, there's a 3 that's multiplying the y, but there's also an x that's adding on to the y. So we want to get rid of that x first. So now here I have a choice about how I write this, right? And we're used to seeing slope-intercept form in a certain way. Okay, if I just write it the way it's written, there's a good chance I'm going to confuse myself, right? It says negative 15 minus x, which mathematically is fine. Okay. But the problem is when we put the x at the end of the equation like that, and I say, hey, if I just I got rid of this, if I said, what's the slope of this? A lot of people will just grab that first number and say, here's my slope. Okay. This is not the slope. The slope is defined as the coefficient of the x, and so the slope would be here. Okay. And so by putting it in the wrong order, we can kind of mess with our brains and make it harder for us to identify the slope. So given that we have a choice about how we write it, we should write it in the way that's going to be best for us. And so that would be to put the x first and then the constant second. So I'm going to write negative x minus 15. Okay. Y is still not by itself, so I'm going to get rid of that multiplication by dividing. And I would suggest that you guys do individual divisions here as you do this. Okay, so notice how I put a 3 under each term. Rather than sometimes people will do this on that right side, they'll just do this. It means the same thing, but again, tendencies towards mistakes run higher here if you do that. Okay, because a lot of people will look at it and just divide this by 3 or just divide this by 3. They won't remember to divide both parts by 3. Okay, but if you write it so that both parts are being divided by 3, it's a lot harder to make that mistake than on the next step. Okay, so just little things like in how you write stuff that can make it easier for you to do the problems right. What I kind of refer to like as what best practices. Okay, so y is by itself now. Okay, make sure that when you're looking at that x, you think of it, there's a negative 1 in front of it. Okay, so there's a negative 1 in front of that. And so as I go to write that fraction, I want to kick that fraction off to the side, negative 1/3, and then my x. Again, I have a choice here about how I write that. I could also write that as negative x over 3. And mathematically, they're the same. But if I look at this and I say, hey, what's the slope here? It's harder to figure out the slope out of this, right? And with this here, you're like, oh, the slope is negative 1 over 3. So they equal each other, but this is harder to read. So why would we write it like that? Okay, so you kick that fraction off to the side, put the x next to it, okay? And then, of course, the negative 15 divided by 3, it'd be negative 5. So it kind of makes sense, like on those kind of, again, those best practices things, how to write things so it's clearer to you, the choices you have, and how to make them in a way that's going to benefit you. Does that make sense, those things I was bringing up? This will be the part where there's like a little spinning wheel and I'm waiting for you guys to answer my question. Okay, all right. So Clover, what's our slope? What was that? Let me try that again. What's our slope? Yeah, data should be negative 1 over 3. Okay. And Clover, the y-intercept is negative 5, so 0, negative 5. What does this mean when we say the slope is negative 1 over 3? What's that mean? If our slope is our rise over our run, and I say the slope is negative 1 over 3, what does that mean? Want to be really careful with Clover. One, I don't like to say over, because over doesn't mean anything, like far as direction. So I go over, I don't know which way I'm going. And then remember that your rise over your run. You have that upside down. So how would you fix that, Clover? All right, so down 1, left 3, okay? Okay. If we were at a point and I went down 1 and then left 3, right, I would end up over there, right? Does that make sense, Clover? So if we drew that line between those, would you say that line has a positive slope or a negative slope? It's actually got a positive slope. As we go from the left to the right, the line is going up. Right? Remember we talked about increasing and decreasing functions. We always want to read those from left to right. So as we go from the left end to the right, increasing, this has a positive slope. Okay. So what's going wrong there with what you said is that if we think about the numbers that are attached to down 1, that would be a -1, and then left 3 would be -3. So -1 and -3 would give me a positive slope, but we need a negative slope. Okay, so you made a really common mistake, which is exactly why I wanted to talk about this. Okay, that when we say -1/3, only one of those numbers is allowed to be negative at a time. So -1/3 specifically means, and if you guys notice when I write it, like notice how my negative sign is attached like more to the negative on the 1 than it is to the 3. I don't put it off on the side like this. I very specifically don't write my fractions like this when they're negative. I don't put it off on the side like that. I didn't do a great job of it this time, but I generally put the negative on the top number. So it's very specifically on that. Because what I need to make sure I know is that only this number is negative. So that's a down 1 and then right 3. They're not both negative. Or I could do 1 over -3, which would be up 1, left 3. Either of those is fine. Okay. So either the 1 can be negative, the 3 is positive, or the 1's positive and the 3 is negative. But they can't both be negative. Okay. Because if they're both negative, then 2 negatives gives me a positive. So 1 can be negative, it can be negative here, and that one's positive, or this one's positive and that one's negative, but they can't both be negative. So if we look back at our point, Clover, right, if I have a point and I go down 1 and then right 3, I'd end up over here. If I go up 1 and then left 3, I'd end up over here. And then I can connect those points with one line. So even though I went different directions, it ends up taking me in the same overall direction linearly. Yeah, that's a really common mistake. Okay, so I'm actually glad that you said that, because that's exactly what I wanted to talk about. Okay, so you guys need to be really careful about that when you're talking about slope. They both can't be negative; only one of them can be negative. So that's why I always put my negative on the top number. I don't like the side like that. Yeah, don't worry about it. Okay. Hopefully that clears up for a lot of people. In that group, grab all this. All right, so I'm going to keep that. I don't want it to go away. Let's look at 10. Okay, so looking at this, right, trying to see if it's in slope-intercept form. So definitely, noticing that y is not by itself. So that's going to be our first, thought there. We need to get y by itself. what should we do to get y by itself? One, okay. So that gives me 4x plus y equals 1. And Peyton's saying subtract 4x. So again, remember we have a choice here of how we write that. 1 minus 4x is fine. Right? Mathematically, that's fine. But can you look at that and say that's the, what's the slope? What's the y-intercept? Okay. So if you're going to struggle with that, then don't write it like that. Okay. Which again, most people don't like it like that. So instead, you're going to write negative 4x plus 1. Okay? I'm not sure what you mean by distribute, Clover. I'm not doing any distribution here. Distribution would be like across parentheses, right? That would be a distribution. So we've gotten y by itself. Brooklyn, what's our slope?
I'm not sure.
What? Where do you look to find slope?
Is it 4? Negative 4?
Mm-hmm. So negative 4 or negative 4 over 1. Okay. Evan, what's our y-intercept? Evan, you there?
Yeah, what? Sorry, what's going on?
What's the y-intercept?
Y-intercept?
Mm-hmm.
Hold on. I don't. 0, 1?
Mm-hmm. Good, Peyton, Tatum, Johnson. All right. Yep. I want you guys to 12. Yep. Send me your equation in the chat, okay? Good, Peyton. Lucas, looks like you forgot your X, but you're good otherwise. Yeah, okay. Something's going wrong there, Natalie. Good hope. I said 12. Yeah. I got a sign issue, Tatum. Tatum, what should our first step be? At 5x, okay. So you should have negative 4y equals 5x plus 24. And then what should we do, Tatum? Get a small mistake, Lily. Divide by negative 4. So y equals, right? And so looking at that fraction here. So negative 5 over 4 x. And then 24 divided by negative 4 is negative 6. Okay. So our slope is negative 5 over 4. And our b is 0, negative 6. Oh, okay. Thanks, Steve. Not sure what you're getting at there, Henry. Oh, yeah, I get that 6 there, Henry. You can see what you should have had there. Does that make sense, Henry? No, Peyton, it doesn't matter if the 4 or 5 negative is negative. And it's just my general habit to think of the numerator as negative. But yeah, it just can't be both of them at the same time. So I've just found it easier over the years just to put that on the top. So. All right. Let's see. All right, we're gonna flip to the other side. As long as you guys are good here, does that make sense? What you guys are doing there, trying to get it into slope-intercept form and find the slope in the y-intercept? Okay. Thanks, Connor. All right. So again, if you're writing this down, you don't need to try to write all this down. Most of it, this big chunk up here in the top it's not a big deal. I will talk about it really quick, but it's not something that you need to write down if you're doing this by hand. So just listen if you're doing it by hand. But if you have it printed out, you can fill in the blank here. So when we were talking about linear relations, right? Why they're called linear relations is because the points on that graph lie in a line, right? You guys, knew that already. We've talked about that a little bit at the very beginning of the year. That when these points would all lie on one line, so that's why it's called a linear relation or a linear function. Okay? And of course, one of the ways we can we can represent linear relations or linear functions with equations. And this equation for this particular line would be this. And it's a little weird because of the way the text came out, but this would be the equation for that line, x plus y equals 8. And so again, if you are writing this out by hand, you don't need to write any of that part down. It's not a big deal. It was letting you guys see that. And basically what that has to do with is that each point on here, so like here's 4, 4, right? So if we take the x value and the y value and we add them together, we get 8, right? And here I have a different point, 1, 7, right? And I take the x value and the y value and I add them together, I get 8. Right? And so every point on this line follows that rule. Here is 8, 0. Right? When I take the x value and the y value and I add them together, I get 8. Okay, so this is a rule defining the points. The x value plus the y value of each point must add up to be 8. And so those are the points that follow that rule. And that's what equations are for lines. They're rules that define the relationship between the x-coordinate and the y-coordinate. Okay, so it's saying that the x-coordinate and the y-coordinate must add up and give us 8. And so those are all the points that do that. Okay. So this line is written in standard form. So those of you guys that are writing out this by hand, I do want you to write like this. Oops. So standard form, what it's going to look like, and then what the rules are. Okay. So standard form for an equation of a line is ax plus by equals c. So that's what standard form looks like. And I wrote it in that way very specifically where the A and the B and the C are large, like they're capital letters, and then X and Y are lowercase letters. Okay. So as far as rules go, as far as when you write something in standard form, A, B, and C need to be integers, which means positives, negatives, zeros, okay, but no fractions. Okay, so we're writing these. Our answers can't have fractions in them. A has to be greater than 1. Which means it has to be positive. Essentially what we're looking at there it needs to be a positive integer. And then this is something we haven't talked a lot about. You guys would have talked about a little bit in Algebra 1. The greatest common factor of A, B, and C has to be 1. And essentially what this means is that the numbers can't have anything in common. And if they do have something in common, then we need to take it out. So, like if I looked at these 3 numbers, if those were the numbers, if those were my A, B, and C, all of those numbers have 2 in common. And so then I would end up having to reduce them to that. Now they don't have anything in common. Whereas like if I had 4 and 6 and then like 7, all 3 of these numbers don't all have anything in common. Like 4 and 6 both have 2 in them, but 7 doesn't have a 2 in it. So these would have a greatest common factor of 1, whereas these had a greatest common factor of 2. And so I can take that 2 out, or can kind of divide it out. And we'll see how that works out later. Okay. I know it's, again, that's something you guys haven't done a lot of, this idea of factoring, but something that we're going to do a whole bunch of in this class. Okay. So we're just kind of rules on how the answers are going to look. We're going to be kind of checking to see this. Okay. So here we're going to be given some equations. We're going to write them in standard form. This is probably something that you haven't done a lot of. But standard form equations are useful when we talk about certain situations. Like slope-intercept form is really nice to graph from. Standard form is not really good to graph from, but it's also often we can write equations in standard form easily. Like if you think of a problem like you wanted to buy, or Tommy bought 4 pounds of cashews and 3 pounds of walnuts, and he spent $15, right? Whatever the price of cashews was and whatever the price of walnuts was, we don't know, but we know, how much he bought and then how much he spent. So that equation would be written that way, which is in standard form. Or if you went to the store and you bought 4 shirts and 3 pairs of socks and you spent $15. That type of thinking lends itself to standard form equations. That's why we like to use standard form equations. It matches that type of thinking. Okay. But you guys probably have not written equations into standard form much. Usually we would try to get it out of standard form into slope-intercept form so we can graph it. So this might be a kind of a new skill for you guys. Okay, so what I want to do in kind of judging the equation to see if it's what I need to do. One thing I want to see is are x and y on the same side. That's the thing I really want to notice about the problem, right? With these x and y's on the same side, with slope-intercept form, y was always by itself. Okay, so what I notice is that x and y are on the same side. So I don't need to worry about that. Okay, so I'm going to put a check by that. Okay. Then are a, b, and c integers, right? Again, no fractions. So -5, 6, and -12 are integers. Okay, so that kind of rule is met. The next thing is a greater than -1, or sorry, is a greater than 1? Well, my a value is -5. So I need a to be positive. And so how do I make that happen, right? It's -5 right now, but I want it to be +5. And so we either need to multiply or divide everything by -1. So I'm going to use division. It doesn't matter if you multiply or if you divide. I'm going to use division and divide everything by -1. So it gives me 5x minus 6y equals 12. So now that's right. Okay. And the last thing I'm going to check is, do A, B, and C have anything in common? Do 5, 6, and 12, are they all divisible by something? Are 5, 6, and 12 all divisible by something? Okay, other than 1. Okay, so they're not divisible by anything, so that means we're good to go. So that means this is done. That's kind of like the rules on like how to do this, what it needs to look like, what are the things we're looking for in order to get it in the right way. So every set of numbers is divisible by 1. Okay, we're looking for things that are divisible by other things than 1. So, okay. So when I say a number, I'm saying any number besides 1. I'll try that again with you guys. Okay. Let me know if something's getting real out of whack where you're not really sure what I'm talking about. Okay, since this is probably pretty new to you. So the first thing I noticed about this problem is that x and y are not on the same side. So we need x and y on the same side. So in order to accomplish that, I'm going to move the 2x over. So I'm going to have -2x. And again, I'm going to put the x in front of the y. So that's what our form looks like. Okay, so now it looks more like this than it did before. Are a, b, and c integers? -2 is an integer, 1 is an integer, 9 is an integer. Okay, so they are integers. Is a greater than 1? My a value is -2. That's not greater than 1. So I need a to be positive. So again, what I'm going to do to make that happen is I'm going to divide it by -1. So now I have 2x minus y equals -9. So now it's positive. And then do they share anything besides 1? 2, 1, and 9. Now, notice I'm not even talking about the signs. I'm just looking at the numbers. 2, 1, and 9. Are they all divisible by anything besides 1? Especially since that's a 1, then it means no, right? So 2, 1, and 9 have nothing in common. And so that means we're done. So as you guys are doing this, like, I don't need you writing this down, like when you're doing it for your homework and stuff, but this is like the thinking you need to be doing. So I'm writing it so you guys can see it, right? You can hear me saying it, but later on when you're trying to go through this, if you can't see what we were thinking in this moment, then it makes it really difficult. Okay. Anything right now that's bugging the heck out of you with this? I want to try to do 2 more with the time we got left. Do 3. So what I notice is that X and Y are on the same side, but that 24 is also over there. Okay. So I need that 24 on the other side. Okay, so I'm going to add 24. We need that C value to be on the other side of the equal sign. Okay. So that gives me 9x plus 6y equals positive 24. And then we start running through those checks, right? Our 9, 6, and 24 integers, right? Again, what we're avoiding here is fractions. So there's no fractions here. Okay. Is A positive, right? Is A greater than 1? Yes. And then the last thing we look at is, do the numbers have anything in common? So do 9, 6, and 24 have a number that goes into all 3 of them? Yeah, right, Peyton, 3. So what we're going to do is get rid of that 3. We're going to reduce it out. Sorry, that's horrible handwriting. So I'm going to take everything and divide it by 3. So that's going to be 3x plus 2y equals 8. Now it's done. So these equations, the parts in blue, okay, ignoring the orange part here, these equations are actually the equation of this same line. If we graphed this and then we graphed that, we graph the exact same line. This is a simpler, smaller, right, reduced version of that math, right? It's just like reducing a fraction. If I say 9/18, it's the same thing as saying 1/2, right? But 1/2 is preferable because it's simpler. These are the same equation. This is just a reduced version of it since they all had a 3 and I could take it out. It would give us the exact same answers, the exact same line. Okay. All right, last one. So first thing I'm checking are X and Y on the same side? Is the number off on the other side? And so that part checks out. Okay. Then I want to see if they're integers. And so this one, the integer issue. These are not integers. Okay. And so what we're going to do is multiply by the common denominator in order to get those to be integers. So if I think about what the common denominator would be, 4 times 3 is 12. Okay. So we're going to multiply everything by 12 in order to fix this. And so just like before, when I had to divide everything by -1 to switch the signs, I have to make sure I multiply everything by 12. So not just those two things, but also the 1 also needs to be multiplied by 12. So 3/4 times 12. 12 divided by 4 is 3, times 3 is 9. So that would give me 9x. -1/3 times 12. 12 divided by 3 is 4, times -1 is -4. So that would give me -4y. And of course, 1 times 12 is 12. So now everything's an integer. A is positive. And then 9, 4, and 12, nothing in common. So that means we're done. Okay. So I fully expect you guys to have some questions about the question, the problems like this that you need to do tomorrow. Okay. It's not that easy, and it's definitely something you guys have probably not done before. So just be ready to have